Okay. All right, folks, let's get started. My name is Siddhartha. I work on the Yarn team at Hortonworks. I've been there for about a year and a half. I mostly work on containerization stuff, Docker, Docker on Yarn, Kubernetes Yarn, Go Hadoop, those kind of things. So today this will mostly be a technical presentation, but before we go there, I want to do a little bit of context setting. So how many folks here are aware of Linux container executor in Yarn? Oh, okay, it's a small fraction. And Docker? Okay, kind of figured. Okay, so Linux container executor is one of the actually four available executor mechanisms in Yarn. So what you can do in Yarn is basically specify, depending on the platform, what your executor implementation and the container engine that's used is like, right? So in Windows, you can use Windows Secure Executor. There's also a default executor that can be used across platforms. And for Linux, we use Linux Container Executor. Now, there's also the Docker Container Executor, which was built as a first integration of Docker with Yarn sometime last year. What that does is it basically runs everything you run on the Hadoop cluster, Yarn cluster, in Docker containers. So what we do here with Linux Container Executor is a more evolved version of that, and I'll be diving into some of the details. Now, why would we want to integrate Docker with Yarn? So this is one piece of the evolving story of running various kinds of workloads on Yarn, right? So today, we have a whole variety of engines, everything from Thais to Spark, all of these, Hive, all of these running on Yarn. And we are also seeing increased traction on being able to run different kinds of services. Now, one of the big problems of dealing with services running on an existing Yarn cluster is, okay, I have this cluster, I have all of these systems set up already, but how do I bring in this set of dependencies that my Spark job needs, right? So if you have, say, two different data scientists who want to come in and say, okay, I need this version of Python, I need that version of R, how do we go ahead and achieve this while trying to, keep our sanity with respect to operating this cluster, right? So Docker provides a nice mechanism in terms of software isolation and packaging. So what we can do is we can bundle all of these dependencies within the image, and we can enable all of these different use cases. So that's the broader context for why we want to integrate Docker with Yarn. Now, moving on to the notion of container runtimes. So in Linux Container Executor, what we did was we added the notion of container runtimes. So what you can do is within Linux, you can now choose, depending on what your application needs to do, what kind of container you're launching, right? So it's, you pick an executor based on the platform you're running, and on the platform you're running at runtime, excuse me, at runtime, an application can choose what kind of container you want to launch, right? So today we have just two. One is the Docker container runtime, and the other is the process runtime, which is basically just launch a process, which is what Yarn already did, right? So in the future, we can look at adding different container runtimes, maybe Rocket, maybe, if somebody is ambitious enough, they can even try VMs. There's nothing that prevents us from doing that. So let's see, this was added as part of Yarn 3611. That's an umbrella Jira that basically was created sometime last year. Now, in the Docker container runtime exposes a subset of functionality that Docker provides and expose it via the Linux Container Executor. Now, we could have gone down the path of providing free-form access to the Docker command line, but that has a whole bunch of security implications. If you're able to run Docker containers, you're effectively a super user. So we sort of need to make sure that not everybody who has access to the cluster necessarily has access to the Docker client itself, right? In addition to that, we also needed to make sure that whatever features we expose related to Docker make sense in the larger context of running Docker containers on Yarn. In terms of dependencies, we need Docker 110x. Some of the work that we are planning in terms of new user namespaces, actually I think you might even need 111 for user namespaces. And you'll need a more recent Linux kernel, 3.10 plus. And if you need user namespaces, you might need an even more recent kernel, right? So this basically eliminates a bunch of older operating systems, CentOS 6, all of those that a large number of people are still running. We sort of experimented with those as well, but we ran into a bunch of kernel crashes, features not supported and things like that. And in addition, Red Hat themselves have stopped supporting Docker on anything older than RHEL 7. So it didn't make sense for the community to go down with anything older than that. And moving on, so in terms of resource isolation, so from here on, what we'll do is we'll take a subset of these features that Docker provides and see how they integrate into Yarn. So in terms of resource isolation, we added this as part of Yarn 4553. So the thing here is that Linux container executor already provides a resource handler mechanism, which basically uses C groups to isolate CPU. Memory was added recently, and disk and network as well. Disk and network are basically fair sharing, and you can't schedule based on those yet, but you can still isolate based on them. Now, Docker provides a mechanism in which you can ask that the container, the process being launched in the container is attached to a specific C group. So what this will let us do is that it will let Yarn manage C groups, resource isolation, all of this, and then tell Docker, hey, go use this C group and attach to it. So the interesting bit here is that anything you do in Yarn, C group isolation, traffic shaping, all of this automatically just works with the new Docker container runtime. Now, capabilities. So Linux has a notion of capabilities where you can basically isolate what processes can do, and Docker exposes this functionality as well. So what we do is we basically provide an admin-controlled cluster-wide setting, which controls the capabilities that containers launch with. So we drop all the capabilities first, and then we say, okay, here are the subset that you can use. The default is based on what Docker uses by default. Now, the thing is, there are cases where we have found this useful, not necessarily secure, but useful. So there are cases where, for example, if you look at cap setuid, right, what that lets you do is it lets you run setuid binaries within the container. So if you want to say, run an SSH daemon in there, right? So you can have a wrapper that lets you launch SSH in there, right? So those kind of things are possible by controlling capabilities. Privileged containers. Now, this is a little more risky. So one of the situations we ran into with some of the internal clusters that we were running is for some Hive-related reason, we had to run Oracle inside a container. Now, some of these, for lack of a better term, old world applications are not necessarily that cooperative when it comes to containers, right? They make assumptions about owning the entire node or wanting to change settings that aren't necessarily exposed inside containers, right? So those containers sometimes need to be run as privileged containers, but given the security implications, this needs to be carefully controlled. So what we do is we provide an admin knob, which allows for a set of users or groups to run privileged containers on the cluster. So you have to explicitly ask that a container be privileged, and you need to be in this list to use this functionality. And of course, it's disabled by default. In terms of users, now Docker runs containers as the specified, it can run containers as a specified users. Now by default, I think if you don't specify anything, it just runs as root, and of course the image itself can have a user spec indicating that, okay, run this as a specific user. Now again, this fits in nicely with the Linux container executor and Yarn security model, because depending on what user you're submitting as and what privileges you have, you can make sure that the container is launched as the right user, right? So this basically lets us do that. Now there are certain implications that we need to be aware of. Like one of the things I mentioned was the cap setuid could lead to privileged escalation. And one of the other interesting things is what the UIDs actually map to inside and outside the container, right? So for example, one case we ran into was in CentOS, nobody's user ID 99, whereas in Ubuntu, I think it's 6.5535 or 3.4 or something, right? So when you try to run a container as nobody, what tends to happen is that inside it runs as Ubuntu's nobody, and that UID doesn't have permissions to write to the container work directory because those permissions UID are based on what's outside, right? So there are all those kinds of implications. So there's still some work here that we need to do to support user namespaces to make sure that we squash any privilege escalation and all those kinds of things. So this is a little bit of a work in progress still. Networking. Okay, so there are some interesting things that are possible here, especially based on the new Docker network plugin support that was added. So by default, we do net equal to host. Again, that has security implications. I think there were somebody who was able to, from inside the container, because they were running net equal to host, actually reboot the host outside. So you have to use this with care. We have to switch this to bridge mode by default, or a networking plugin that an administrator could configure. Now, the problem here is that with some of the applications and engines that run on top of Yarn, they kind of coexist. The task process expects to be able to talk to the node manager and ensure that it's part of the same network stack and things like that, right? So if there's a mismatch in terms of IPs or hostname and those kind of things, some applications just fail to work, right? MapReduce, I think, is one of them, and I think that's the case even with Spark. So that's the reason why it defaults to net equal to host right now, but this could change in the future. And if you use Docker's network plugin support, you could do more sophisticated things. If you're not tied down by the requirement that you share the node manager's network stack, you can do things like, okay, your plugin assigns an externally addressable IP address so that all your containers now basically are in their own address space. And now if you add DNS on top of that and service discovery, you now have basically your mini container cloud running on top of this, right? So all those kinds of things are possible if you use the new networking setup. So right now it's actually already possible to use one of the plugins that the Docker daemon has started with. But the thing is that there is no validation or checks to ensure that it's from a limited list, or it's only based on what admin has provided and things like that. So there's a Jira for it, Yarn 4007. We need to do some work to make sure that this is controlled in a better fashion. All right, images. So this is one area where there's not a lot of work that's been done yet. So the thing is that there are several approaches that we could take here for localization of images. One of them is HDFS, where each application could point to an archive, say on HDFS, and say that, okay, download this and then do a Docker load so that that image is then available for that running task. Now, there are a bunch of issues there. Again, one of the things is that it sort of does away with a bunch of optimizations that the Docker registry can already provide. There's things like security, signed images, and all those kinds of things which no longer work. And it's also possible that depending on what you're loading the image as, you could basically squash somebody else's images. So you have to be a little careful there, right? So the other approach that we could possibly use here is integrate directly with the localization mechanism that Yarn has. So what localization does is that before a container or an application process actually starts up, Yarn can download artifacts from a central location, usually HDFS. And once it does that, it then launches the application process. Now, instead of downloading an archive of the image, what we could instead do is do a Docker pull of the image in that same phase to make sure that the image is downloaded from whatever registry is available. Now, again, there are certain implications there because the way the localization mechanism communicates with the node manager, it needs to report status and needs to report health every so often. And if the Docker pull takes a really long time, it may be considered to be a failure, right? So there are pros and cons with each of these approaches, so we sort of have to figure out what to do here. Now, one of the other disadvantages of just using HDFS and loading images is there's no way to namespace these images correctly. So that's more of a, I guess, a Docker limitation in some sense, that if two different users want to use the same name for the image, that's not quite possible unless you namespace them somehow. So we have to figure that out as well. So that's about the registry bits. So enough talking. I think we should do a couple of demos. So I'm going to try a couple of live demos here. Hopefully the demo gods will cooperate with us today. So the first one is Spark on Docker. Like I mentioned before, this is something we hear pretty frequently, where we basically have users or even customers of Hortonworks coming and saying, okay, we have these half a dozen data scientists who want to do all these different things with Spark, with all these different dependencies. Is there a way you can make this happen? And from a Hortonworks or a vendor perspective, it's like, okay, now if we have to ship these 20 different dependencies or 20 different versions of Spark, that's not going to scale either. So what we can do instead is we can create Docker images for these different versions of Spark with their different dependencies, and then just use them on the cluster. So let's see. Okay, I'm going to do this entirely offline. So there's a single node VM running here. As you can see, there's basically one node manager, and there are no applications running here at this point. Now, going back. Right, so there are basically 4 different scripts here. 2 of them are for running Spark clients, and 2 are for submitting Spark job. So what we'll do is we'll take a look at one of these. So even for running the client itself, I'm using a container. There's net equal to host. The configuration from the cluster is being mounted inside the container is read-only. And of course, that is being exported as an environment variable. And Spark already has a way of injecting environment variables into Yarn when launching containers. So we don't have to make any code changes to Spark to basically use the Docker integration on Yarn. So we'll start both of these. Okay, now if you look at the basically 2 client containers running here, and before we actually get started, let's take a quick peek at the VM itself. So this is running a fairly recent version of Docker and running rel 7.1. And of course, the usual Hadoop processes are all here: Node Manager, Resource Manager, and HDFS as well. Okay, now let's take a look at, again, Spark submit looks pretty similar, except for the fact that you're injecting these environment variables to specify what images you want to use for launching these processes. Oops. Okay, let's start both of these. So this container basically came up and vanished pretty quickly. That job finished. 1.4.1 was still running. You can see that container. Its worker came up. There you go. Both of those ended up finishing. I'm not going to show you the value of pi, which I'm sure all of you already know. But yeah, so with this, in this fashion, you can basically run different Spark versions on the same cluster. Now, you can take a look at a different demo, which sort of lets you do more interesting things. So, okay, so what we'll try to do now is try to run yarn on top of yarn. So one other use case that we have seen sometimes is that, okay, you have this base yarn cluster, it's been stable, it's been running for a while. Now what do you need to do in case you want to try out some new version, even test some changes and those kind of things, right? Your HDFS instance may still be outside and still be shared by a cluster. You may want to use that HDFS, but run a different version of yarn, right? We see this scenario internally when we are trying to test changes that we are releasing. So this is one of those scenarios where using containers is kind of helpful because, again, all of those dependencies can be bundled and you can deploy those images. So, okay, so we'll take a look at this. I'm going to use distributed shell here because we only need to run a one container Hadoop installation here. If you want to run a more elaborate setup, we can use something like Slider, which lets you specify different set of components and dependencies, order of deployment and things like that. But for this demo purposes, we'll just use distributed shell. Now again, here you'll see that there are shell environments, variables that are being injected to pick the container type. And again, you see the network type here is bridge, which basically says that Docker uses its default bridge mode of networking to assign an IP address. Now, one of the disadvantages of using bridge is that these are local IPs, local to the node in question, so you can't really access them externally. I don't have a different network plugin running here, but we have actually done that where you can assign externally addressable IP addresses, and of course, you can access those IPs elsewhere. Now, what we'll do instead is once we spin this up, we'll actually create a tunnel so that we can look at the yarn UI for the yarn cluster that's running inside. So going back to the UI, you can see that those two examples finished. Distributed shell just started, it switched to the running state. Now let's take a peek inside what got actually launched. So the yarn invocation of Docker is actually fairly involved. So if you look at the Docker run command, this is what it looks like. So the container name is based on what yarn already creates, and because we want the application process to run as user nobody, you can see that it runs as nobody. The work directory is again based on what the container work directory is. This is similar to the mode in which you can run applications outside of Docker, right? So yarn creates container work directories which something like Spark or Stays or any of these can use. So even though you're running inside a container, these work directories are still created, but they are mounted into the container so that when you actually do all your work and generate that data, they are available outside as well. Of course, here are all the capabilities that we discussed. The user accounts are mounted read-only in there, and you'll also see C group parent. This basically says that attach to this C group, which yarn created under the Hadoop yarn hierarchy. So all the resource isolation is basically handled by yarn. And of course, the container launch script itself is the command that's basically executed in there. Now, what we'll do is we'll actually go into this container, right? And these are all the Hadoop processes that belong to the container itself and not of the node outside, right? And of course, you can do this. It basically shows that you're running as the right user. Now, what we can do is we can basically grab this IP address, and we can, let's find a local port. So you have this cluster that's running inside this container, and you can see its version and all of that. If you actually see nodes here, you'll see this hash, which is basically generated by Docker as a host name and name of the container itself. Okay, that was basically it. And of course, if you, like I said, if you switch network plugins, you don't have to do tunneling and all of this stuff. And there's work going on actually enabling DNS and service discovery in Yarn. So there's already a service registry, but it's a chatty API. You actually need a thick client to interact with it. We're adding DNS, stateless DNS service on top of that so that you can use that instead of building a specialized client for it. Now, once you do that and once you use your own network plugin, now you basically have the services that are discoverable, accessible externally, and so on and so forth. All right, so that was it. And it looks like we have some time for questions.
So does this work in a Kerberized cluster, unchanged?
It should, because we are using LCE, which was designed from the ground up for security anyway. So I expect it should. We haven't done a lot of testing on that yet, though.
And I noticed that you were pulling in the local Etsy password if you're running directory services connected to LDAP or Active Directory.
Yeah, that's
pull that in as well through the OS level. We use an SSSD.
Yeah, so honestly, I don't know the answer to that. We still have to do some testing and figure that out. Even the Etsy password was something that we imported from the earlier Docker container executor. Because we haven't actually done a lot of Kerberized testing, we don't really know how this will play out yet. So we need to figure that out. So let me repeat that question. So your question is, do the processes running inside the container have a unified view of the cluster, or? Okay, so depending on how you inject configuration, you can make sure that they can talk to the HDFS that's running outside, or so it really boils down to how you set up your networking. So if you say net equal to none, that's an option as well. Then the container is completely sandboxed, right? Which has its own limited set of use cases, I guess. So on the other hand, if you make sure that the container is has an IP that's fully addressable and DNS works both ways and all those kinds of things, then you can access services that are running elsewhere on the cluster as well. So it's really up to how you set up your SDNs and networking, those kind of things.
From a processor, memory, runtime specification perspective, this is a single data node, specified data node.
I'm sorry, I'm not able to hear you very clearly. Could you please repeat that question?
From a CPU perspective,
Yeah. The container from a CPU perspective, it's running on a single node. It is. I mean, each of these individual containers basically run on a given node, and the resources are managed by Yarn. So the thing is, when it comes to managing cluster resources, that still doesn't change. So when you do scheduling based on CPU or memory, that's still a cluster-wide view even for these containers. So that doesn't change. That's a good question. So to repeat the question, do we have best practices for how we use HDFS in this scenario? The short answer is we don't. The thing is that there are certain things that don't necessarily work well here. Short circuiting doesn't work, and you have to be careful of how memory is used between the HDFS client and talking to the local data node and things like that. So right now, the behavior is that if the container has its own network stack, it's as if there's a remote service talking to HDFS. So you get that kind of performance and that kind of behavior. Not necessarily, you don't get the advantages of running a local data node, basically. We hope to figure out some of those things as we do work on volumes and figuring out how to make sure that HDFS works well in this scenario. It's somewhat of a work in progress still. All right, that's about it. Thank you.